Chapter 10, Freshwater and Water Pollution. In this 10-minute lecture video, we're going to talk about the importance of water. We'll go through some water resource problems. We'll discuss water pollution and briefly talk about strategies for improving water quality. So first of all, kind of basically, when we started off with talking about air and air pollution, we started talking about the importance of the atmosphere and what it does for our planet. So let's talk about the importance of water and what it does for our planet. Essentially, life as we know it would be impossible without water. All living organisms contain water. Humans ourselves are 60% water. Not only are we made up of water, most of our daily routines revolve around water. We drink it, we cook with it, we wash with it, we travel on it, we use it to make our food, we use it to make everything else, manufacturing, mining, energy, waste disposal, you name it. So not only do we as living things depend on water just to survive, we also depend on it in order to have our society and our culture. The problem is that even though we have a large planet with what seems like an awful lot of water on it, less than 3% of the water on planet Earth is actually consumable. 97% is in the oceans. That's great for fish and marine life and everyone else who needs oceans, but for living things, we need fresh water to survive. All that water is not evenly distributed either, which means that we have regional supply issues. And we have seen that as the future continues, we will begin to see more and more places where we see people that will have inadequate supplies of drinking water. So this graphic here kind of breaks down the water. So if you look at all the water that's on the earth, about 2.5% is fresh water. Of that fresh water, most of it is locked up in glaciers and permafrost. And then some of that is actually in groundwater. And then this little part here, surface and atmospheric water, this little 0.4%, we're going to take that out. This is freshwater lakes. So this is just surface and atmospheric water. 2/3 of it are found in lakes, soil, atmosphere, wetlands, rivers, so on and so forth. So when you break it down, there's very little fresh water available, and most of it is for the agricultural industry. Almost 70% of what we're using is just used to grow our food. Real quick, the water cycle. If you've forgotten the water cycle from grade school, we talk about evaporation, right? So evaporation of surface waters, okay, into the atmosphere. Condensation is where the water droplets cool, form clouds, and precipitation is where the moisture falls out of the clouds and goes back into the water. So just remember your basic water cycle: evaporation, condensation, precipitation. Water can be found in two big places: surface water and groundwater. Obviously, just as it says, surface water is precipitation that remains on the surface of the land and does not seep through the soil. So these are your lakes and your rivers and your streams and your ponds, for example. Groundwater is a supply of fresh water that is actually stored underground. So this is the water that has percolated through the layers of soil into these underground aquifers, which are basically pools of water underground. The thing to remember about groundwater, it's actually considered a non-renewable resource because it can take anywhere from hundreds of thousands of years to form an aquifer. So groundwater aquifers are something that we treat as a non-renewable resource. So with this water and availability of water, we talk about problems with water resource problems. They fall into one of three categories. Generally, you can have too much water, too little water, or your water is not good quality. Too much water, what do we mean? Quite simply, it's flooding. Flooding happens anytime we have more precipitation coming down than our natural channels can hold. And our natural channels are things like rivers and streams and tributaries and things like that. So what happens is these are all places that are meant to hold water, wetlands, those types of things. When the rain comes down too fast and these natural areas can't hold their water, it spills over into what are called floodplains. The problems with floodplains is that humans tend to remove water-absorbing plants and everything that's on the floodplain that's meant to keep the water on site, and they like to build there. We like to build our homes and our businesses and our make our farms and everything else on the floodplains. Okay, well, that's fine and great and all, but what we have to expect is that every so often we're going to get actual flooding water onto those plains because of the fact that we've removed the plant cover and we've built there. So you can kind of think of it this way. If we had a natural area, okay, no buildings, okay, so what happens is of all the precipitation that's falling on the ground, about half of it gets drawn into the ground itself. Some of it runs along the surface into lakes and streams, okay, and about 40% of it actually is taken up by the trees. Okay. Now go to the same place, but now we've actually built something. There's a town here now. What we see instead is only about a third of the water is going into the ground. 43% of it is now running off because we have all these impermeable surfaces. Roads and pavement and sidewalks and all of those things don't absorb water. So instead of water runs. And then about only 25% of it is actually taken up by trees and transpired back into the atmosphere. So we have a big difference with what happens with storm water in a natural area versus an urban area. And of course, we see the consequences and the results of flooding every year. Every year there's an area in the United States where we see problems with flooding, usually along a major river, like a Mississippi River, or it might be in areas that had been very, very dry for a long time. A lot of vegetation died. Then all of a sudden they get a lot of rain and there's nothing to hold the soil in place and you have mudslides, which is what was happening in California the past few months. The other end of it, too little water. Okay, if you don't have enough water, you're in the too little water category. There are places where in the United States, especially in the, for example, the desert Southwest, where they never receive that much rain. They're not supposed to receive that much rain. It's a desert. That's kind of the whole idea. However, that hasn't stopped people from not only building and living in deserts, but we've even decided to farm in deserts because the abundant sunshine means a longer growing season. So how do you grow a bunch of crops in an area that don't receive a lot of water? Well, you have to irrigate. You have to bring in lots and lots of water, and you have to water your crops artificially because there's going to be no natural rain. And that's where we have about, again, 70% of the world's total water use is just used to grow crops, specifically in areas that don't receive enough rainwater to support crops. Another type of too little water problem we can have is when we deplete our water sources. I kind of talked about aquifer depletion. That was this idea that we're pulling groundwater out of the ground faster than the earth can replenish it. It takes a long time for water to percolate through down into those underground aquifers. And so if we pull water out faster than it can go back in, we're at the we might potentially run out of water and have to move on to a new source. We can also overdraw surface waters, not just groundwater, but surface waters. So what happens is we can see habitats change. The soil, the sand gets too salty, for example, and the ground species can't live there anymore. There are a whole host of water supply issues in, again, mostly places that are dry, in the West in particular, southwestern United States. But even places like Florida have problems with saltwater intrusion. Too much salt actually is coming into the groundwaters because we're drawing groundwater out too fast. So what do? We aim for something called sustainable use of water, just like this theme of sustainability keeps popping up around us. Here it is again. If we use our water resources wisely, there's no reason why we can't have a preservation of the functioning of the hydrologic cycle, which means essentially if we're careful with how we use water and we don't waste water, there will always be fresh water available for future generations. But we need to do things like not waste water, improve efficiency, reuse and recycle water, those types of things. We need to put a higher premium on water. If water's cheap, people don't tend to value it. So some people have suggested that if we increase the price of water that we pay, that would be less likely to just waste water. So then let's talk briefly about water pollution. So this is the other water problem. So you have too much of it, not enough of it, or it's not clean. So there's all kinds of things that would qualify as water pollution. We have sewage and sediment and inorganic plant matter and organic compounds and inorganic chemicals, thermal pollution, that's heat. So if the water's too warm, things can't live in it. So there's a whole host of different things. This table from your book actually is really good at kind of describing all of these different sources of water pollution, what the examples are, and some of the effects. So definitely take a look at that table. Water pollution can enter one of two ways, through what's called a point source or a non-point source. Very specifically, a point source is a specific place where pollution is entering. A pipe, a sewer, a ditch. You very clearly know, oh, that's where the pollution's coming from. Non-point source pollution is just that. It's pollution that enters into water over a really large area versus a single point of entry. So for example, if we have road salts that had been used during the winter to melt the snow, all that snow melt with the road salt in it will then run off, and then it runs off into a creek or a stream or a river. It's a large area. There's no one specific place that's entering into the water stream, but that's non-point source pollution. So again, the idea of point source, a very clearly marked pipe here, versus non-point source, which can be your driveway, your roof, your lawn. If you're using fertilizers, there can be a whole host of ways that pollutions can get from your yard into streams. So what do we do? How can we improve water quality? Well, here in the United States, we have two very successful laws, the Safe Drinking Water Act and the Clean Water Act. The Safe Drinking Water Act put into place a series of federal standards, uniform standards that say drinking water has to at least be this clean. And they give you a maximum contaminant allowed level. So you can have no more than this in the water or no more than that. And they give you exact amounts, for example. The Clean Water Act actually was looking at more or less the wildlife and the things that live in the water. So it was ensuring the quality of the rivers, lakes, streams, coastal waters, so that people could actually go out and enjoy these things. So there would be fish that live there and birds that eat the fish, and we could swim in the water and we wouldn't get sick. So these are two different pieces of legislation that have greatly improved both our drinking water quality and also just our enjoyment of water activities as well. In developing countries, it's a very different story. About 1.5 billion people don't have access to safe drinking water. 3 billion people don't have access to sanitation. We see 250 million cases of water-related illnesses a year, and about 5 million or more of those cases result in death, simply because we don't have, most places, a distinction between sewage and drinking water. So what happens in these poorly developed countries is raw sewage is being dumped directly into the same place where they're drawing their drinking water out of. And people aren't, and some of these countries, they're not treating their drinking water first. So the women go down to the river, they fill up a bucket, they come home, and that's the water that they use for everything. So what it means is that you have a whole host of unsanitary conditions which lead, unfortunately, to all of those deaths related to illnesses from drinking water. So that's it for this chapter. Please go back and make sure that you review my notes carefully to look over the parts of the lecture that I did not get to in my overview today.